I'm Christine Kirkpatrick from the US Go Fair office, which is housed at the San Diego San Diego Supercomputer Center. I head the Research Data Services Division, where we work on trying to help researchers with a variety of infrastructure and data services. I'm really excited to welcome you to the first webinar. We have one every Wednesday, although note that the 3 after this will start at the top of the hour, so slightly later. So that will be 9 a.m. Pacific, 12 Eastern, and then 6 Central European time. Next week, we'll be having someone come talk about VODAN Africa and how they're building up capacity for trainers and data stewards there. Then the week after, we will move back to VODAN and look at one of the works in progress. And then the week after that, we will have 3 different projects report on how they're fighting COVID-19 by mining insights from heterogeneous data sets. So with that, I would like to introduce Professor Dr. Barend Mons, who comes to us from the Leiden University Medical Center, wears many hats. What I've got up for you right now is hopefully you saw this op-ed piece that appeared in Nature just a couple weeks before, a week really before this crisis began in Europe, calling on funders to invest 5% of research funds to ensure data are reusable. He, among his many titles, the founding of GoFair, he also is currently the president of CoData. And he's professor of biosemantics at the Human Genetics Department at Leiden University Medical Center, where he has played a role in the international development of data stewardship for biomedical data, and of course, how that's carried over to several domains. One of the authors on the original FAIR paper that coined the term. With that, Barend, let me stop my screen share and turn it over to you.
Thank you, Christine. It's a great honor to be the first speaker in this eloquent series that is quite interesting. So let me share my screen and give you an overview of a number of things that we are doing here. Let me first go to the first slide and then show you this. So a few words before we go into details. Does everyone, I suppose you see my screen now, Christine?
Yes, perfect.
Okay. So we have this GoFair is a set of a whole series of implementation networks that are internationally coordinated, and Christine does this kindly for the US. We have, of course, a Dutch office in Germany, in France, and now also in Austria, and China and Brazil are also already active. And we focus on any implementation that is related to FAIR data. And I am not going into FAIR data in general because I've given many seminars around the world, but I summarize FAIR nowadays as either fully or federated AI ready data, or even simpler, the machine knows what I mean. So we try to bring all data in a format that is reusable, that's not the same as open, and we try to share them. So for COVID, we were suddenly approached by lots of people, can you coordinate actions? And we decided to call this new implementation network the Virus Outbreak Data Network, or Data Access Network. We still fight about that a little bit, but it's fun. So, and this is a typical but it grows like crazy. And I will tell you today a little bit how we try to manage that now, and a few of the examples of what we're doing in that. And everyone on the call it would be able to go there straight away and also be part of it. So if you look at the current website, one of the things I'm very proud about is that this whole initiative is now not any longer just a GoFair initiative. It has been co-branded by CoData, the Committee on Data of the International Science Council under UNESCO, where I'm the president, GoFair, of course, RDA, and Christine could say some words about it in the Q&A maybe, and the World Data System, which is more the repository side of things. And they also made, this is the latest screenshot of the website, a full statement of these 4 organizations on what we feel we need to do in terms of data on the virus outbreak. And as you can see here, we call them FAIR is also federated and AI ready data. So a little bit of an explanation on the background terminology that we use. As Christine already said, we had this original paper, the FAIR Guiding Principles, that got 2,300 citations by now very quickly. I'm not going into the FAIR principles themselves, you can read them there, but we have the feeling that a lot of people, cite them as lip service, but they really do not follow them entirely. So a little bit about the terminology that I will use. The FAIR Guiding Principles are nothing else than principles that we published in 2016. Then we worked with several people actually on this call. I recognize some names. We're very involved in taking the FAIR digital object, where FAIR is a little bit between brackets here because it was not entirely FAIR yet in the beginning, and the linked data platform to bring it into what we now call the FAIR digital object framework. Rob Quick is on the call. I think he is one of the people that already made an infrastructure around it. And that is what we call here as the center. So every FAIR digital object in this framework is understandable by machines. So the machines encounters it, could be a single identifier or a triple, a graph, and so on. And the machine encounters it, and it knows the answer to 3 questions. What is it? The type. What can I do with it technically? Which HTTP calls and so can I do? And what am I allowed to do with it? Because FAIR is not the same as open, which is very relevant to VODAN, because many of the data that are in the local hospitals and CDCs will never be shared outside the country, most times not even outside the institute. For example, my vice president from China, Jianhui, cannot even get the data from his own CDC to share with us so far, because they are afraid that even when we do data visiting, which I tell a little bit more about later, that the trains, as we call them, the algorithms that visit the data will carry spyware. And of course, as a blunt Dutch guy, I was teasing them that they should know how to stop that because they usually create it. But anyway, but of course, as long as some presidents say that it comes because the stupid Chinese eat bats, and the Chinese say that Trump dumped the virus in Wuhan, I know that people will not send their data to WHO. So we need to be very careful here. The data should stay in the countries, the real world data on patients. That's one very nice application of FAIR digital objects, and we can visit them. And then we have the FAIR implementation profile, and we now are building one for COVID-19 that is describing, if you refer to a virus, use this ontology. If you refer to a protein, use UniProt, to a disease, UMLS, etc., etc., etc. So we make implementation choices to make FAIR and reusable data in COVID. So that's a little bit about the technology and the terminology, but I try to keep this short because there are many more other interesting things to discuss, and we can always come back in either Q&A during this meeting, or you can find a lot of information about this online, or ask Robert or ask Luis or any other people that are actually developing this. So the basic thing of our infrastructure that is now also accepted by Géant and Fraunhofer and TNO, major institutions here in Europe, they will build this infrastructure, and they use COVID as a very nice first use case. Principles are, we will support human to machine, machine to human, and machine to machine interaction. It's all based on the FAIR guiding principles and the FAIR implementation framework. All elements where possible are machine actionable, and we make them as open as possible, but as closed as necessary, like patient data in my hospital, in LUMC, the Leiden University Medical Center. We cannot make them open, of course. And it will be as distributed as possible and only centralized if there is no other way. Then you have applications somewhere, data sources somewhere. The machine doesn't care where they are. And the infrastructure or the CPUs to run your algorithm on and they have to find each other very effectively. Several companies that work with us, and I will mention some of them later, already have this running. So you can have any application and run them on any data, but they typically sell this thing to the pharma or to other institutions as a silo. So how we make this, what we now call the Internet of Fair Data and Services, how do we lift this to a globally open, fair system? Well, our approach would be, that we actually use the same thing. The applications have fair metadata. The data have fair metadata. That doesn't necessarily mean the data have to be fair and machine readable themselves. The metadata could say, this is a stupid Excel sheet. You have to do a lot of work to make it work for machines. That's fine. Or these are pictures in DICOM format. But if my application is a learning algorithm that wants to look at 5 million DICOM pictures of breast cancer and learn patterns, that's fine. As long as the metadata are fair, I'll find them and run my algorithm wherever the data are. You would say, yeah, but you need the infrastructure locally to do that. But if these pictures together are 5 terabytes, downloading them is also not a very good option. So you could do distributed learning over these data, and you do that via so-called fair implementation profiles, so you know what you expect at the other end. This sounds maybe for people that are still thinking in data warehousing as a strange way of doing things. So my first slides, if I give normal lectures, are the end of data sharing. And then people get confused and no, we are now doing data visiting. So it's distributed learning over data that never leave their silo. If you go to the website, by the way, you find a link to the personal health train and you see movies, how we do that. So one of the things that we do is here, but I will come back to that. Is there a question or? Okay. Okay, so one of the things that we will see now.
Barend, just go ahead and unmute yourself. I muted everyone. I think you're still on mute, Barend. There we go. We can hear you, I think,
Okay.
now.
I'm muted.
Okay. And I'm writing the Zoom controls hard.
So there is one need that we have is to suck up all new information coming every day and then annotate it, but I have a better slide on that now, so I will continue on this. So this is, but one of the things that we do now very quickly for Corona is we have a company called Data Biology that has this routing, but we also have Rob here who has a routing system already. So anyone can contribute on this search engine and finding stuff and routing stuff. We have Surf in the Netherlands, the Chinese cloud, supercomputer center, if you need to have high performance computing or whatever. We have CEDAR, Mark Musen, Castor in the Netherlands, and DSW in Czech Republic, where we have forms that actually create RDF if you fill the WHO case report form, and they form automatically RDF according to our fair implementation profile already. Boston Consulting Group. The Philips Foundation has already given us 84,000 euros to help to connect a lot of African countries, and Miriam, as I understood, will talk about that next seminar. And then anyone who has clever algorithms can also run them on this system. So we actually use, this is also our very simple model for the European Open Science Cloud, and we use COVID now as a pressure cooker way of getting a prototype of that going. So what Eric, I don't think Eric is here, but Eric Schultes is already doing is with a small project that we already got funded very quickly under VODAN. We are working with China, Italy, the Netherlands, Italy, and a few, Ireland to show, and Uganda, to show that we can have these local fair data points with electronic CRF data in fair format, and that we can send algorithms to those places to do distributed learning to find patterns in the data. And of course, we need a lot more data than just patient data. We also need all the databases in EBI and everywhere, but those already are partly in FAIR format. So we concentrate in this particular project on patient data. And then we can visit those data all over the world. And of course, I use the old map, but now we all know that North America became the epicenter. There's a lot of places in Europe. And if all of these countries would have FAIR data points that contain patient data in FAIR format, we can send algorithms to say, is it true? I just take the example that I told Christine right now, that my own wife lost her taste and smell, which appears to be a very frequent symptom in COVID, and for example, why are males much more susceptible than females to become severely ill? What are the comorbidities? If you want to find these kind of patterns, you better be able to do that in a distributed way, because people will not send their data to WHO. You already can visualize right now a lot, like here's the mutations to the virus during spread. This is what we got from the Chinese, how they visualize the distribution over provinces and, you know, flattening the curve. And one important thing is that you see here that people already start to say everywhere, including the US president, that you can use chloroquine to treat COVID. And we know that can be extremely dangerous in some cases. And I tried to find out already why in a graph system that I will show you in a minute. And we have already a very clear mechanistic explanation why chloroquine may be deadly dangerous for some people with comorbidities. And although the drug has been accepted for malaria and other diseases many years ago, as you probably know, when even Trump said on television that it was approved by FDA, 3 people in Nigeria who had it, of course, in their homes for malaria took it and died or almost died. I don't know exactly, but I think Bob Hainish even said they died. So this is really dangerous stuff. We have to be careful that we do not react in panic during an epidemic like this. So this is one of the other projects we set up, and we just had a call before this call. And to my big surprise, we had enough people already in that VODAN cluster that this is already working. And I was thinking it would take us another half year. So this is a pipeline, and they already ingested the 29,000 articles that Elsevier made publicly available. They did the sentence splitting, the chunker, concept indexer, and we find new concepts like COVID-19, which is not yet in UMLS, of course. And we found new assertions. So let's see, there is a new assertion that never was seen before, like chloroquine treats coronavirus. Then students can help to say, yeah, this was properly mined, but they cannot yet say whether it's true or not. Then it goes here. And here we have professionals with their ORCID and their publication list that will have an immunology room, a drug repurposing room, an epidemiology room, and so on. And they can connect to the graphs I will show you in a minute. And they can then vet this information and say, yeah, maybe 5 people benefited from chloroquine treatment, but it can be very dangerous for people with the following comorbidities or an overexpression of the ACE2 receptor. And only that information that has been vetted by top experts in the world, and many of them are now also sitting in isolation at home. So they actually told us, we have time to look at this. They will annotate at the cardinal assertion level, so they see a triple chloroquine treats coronavirus. They can comment on it and say, I don't believe this, and so on. And then we can feed the group of Fauci or the group of Ursula von der Leyen that she just had as a crisis team for COVID in the European Commission with vetted information, and all kinds of companies can visualize that and say we only base our maps and our graphs and so on information that makes sense and not just misleading people with a lot of crap information that come in here. But one of the sources can, for example, be the patient self-reporting app. As long as you know the provenance, this is patient self-reporting, it's no problem, because from any assertion you find in this room to be annotated, you know the full provenance, where it comes from. You can go back to the source and make comments. So this is one little thing I did on the TMPRSS2 cleavage that is needed to activate the ACE2 receptor for the virus to go into the cell. I don't know how many of you biologists, but that's a very interesting thing. And chloroquine also is interacting with many genes, including via TNF, that interacts directly with TMPRSS2, and that is then activating ACE2. And it gives you an immediate insight on how this could work and why it could be dangerous for some people. And then we had another, this is the way this works in biology. And then we got this other drug coming in from a recent Cell paper. And again, immediately you see that this is connecting with lots of other diseases, obesity, acute respiratory syndrome, all the arteriosclerosis, a lot of the comorbidities you find in the typical patients that get atrial fibrillation and lung diseases, and they are much more susceptible. And you see that some of these, the chloroquine, hydroxychloroquine and chloroquine have pretty different ways in how they work with this. And this came up in the recent Cell article that is not yet published, but was in a preprint. Common-state mesylate is inhibiting this TMPRSS2, and of course in the Eurytos graph that's already very well known. And it relates to ACE2 and PP-para. And then you see, again, it is highly associated with these other comorbidities. But if you then simply ask the system, okay, if this drug works, and it works in vitro at least, and in mice, which other drugs are close in the conceptual space? You can see that we get a whole list of drugs here, and we already reported that we should also test because they inhibit the same cleavage enzyme, so they will actually also very likely influence the entry of the virus in the cells. And maybe you find a drug that is not dangerous for the other comorbidities. So that's the drug repurposing example that I want to show you, because Christine also asked to show me something about Eurytos. And in the next few weeks, I will spend probably every day 2 hours in a room where people can, tell me, add this drug, do this, and change the graph. Finally, a few slides on the phasing of this project, and then we can go back to the website and how you can all join, and we have Q&A. So we start with this very short project, then we ask if we have the fair implementation profiles. We ask approval by the World Health Organization and the GlobeIT-R, which are the funders, and of course via CODATA, UNESCO. And then we will move on and say that everyone can start putting their clever algorithms on these data, and maybe people still find evidence-based interventions for this epidemic. But we made a very strong statement also to the ORFG, and I think Chetan and others were there when we also presented to NIH, NSF, and NIST and so on, that this is not going to miraculously solve this epidemic, but of course we will have now a system